Save the date for .NET Conf 2019, September 23rd through 25th. .NET Conf is a free 3-day virtual developer event co-organized by the .NET community and Microsoft. This year, .NET Core 3.0 launches at .NET Conf, so you don't want to miss this. Over the course of the 3 days, you have a wide selection of live sessions that feature speakers from both the .NET product teams and the community. You will have a chance to learn, ask questions live, and get inspired for your next software project. We'll have presentations on .NET Core and ASP.NET Core, C#, F#, Azure, Visual Studio, Xamarin, and much more. Head to www.dotnetconf.net. That's .NETconf.net to learn more and tune in.
We're here today in on.NET talking about state at scale in serverless workflows using something new and magical called durable entities. You won't want to miss this. Check it out on on.NET. Hello and welcome to another episode of on.NET. I'm your host, Jeremy Lickness, and I'm here today with the Durable Functions team. I've got Sebastian and Chris with me, and they're going to talk about some of the latest features that are coming out with Durable Functions. So before we get started, Sebastian, why don't we start with you? Tell us a little bit about who you are, what you do with Microsoft.
Right. So I've been working at Microsoft Research for about 10 years. And I recently got interested into serverless programming models, and I found that it was a great opportunity to work with the Durable Functions team on this. So I think we are sort of at the cusp of something big in the serverless world. And bringing state back into serverless, I think, is where I'm at. So yeah, that's what I'm here for. That's why I'm excited.
Yeah, it's very exciting. So this is coming straight out of Microsoft Research then?
Yeah, so, well, it's a coordination of efforts, I would say.
Okay,
so we
great.
both brought a piece to it, yeah.
Nice. And Chris?
Yeah, so I'm an engineering manager on the Azure Functions team. So I own my team owns various parts of the platform, but one of my favorites to work on, they're all kind of favorites, right, is Durable Functions. And so that's a project I started back in 2017 now. I think it was actually a hackathon project, but since then it's kind of grown, again, with the idea of kind of creating a new way to do like stateful serverless patterns.
So it's a very exciting framework. I know when it came out, there was a lot of excitement on our side, and I've been working with some of the latest bits, having a lot of fun with what's happening, but more importantly, seeing how these would apply to the enterprise and to actual workflows that people need. So tell us a little bit about durable entities and what's new with the framework.
Sure, yeah. So recently we kind of announced that we're doing a Durable Functions 2.0. And one of the kind of flagship features of Durable Functions 2.0 is a thing that we call durable entities.
Okay.
And the way to think about durable entities is these are effectively serverless virtual actors.
Okay.
So I've got a couple slides here which I can give a little bit more of a deep introduction, if that's all right. But anyways, with Durable Functions, at least in 1.0, there are a whole bunch of stateful patterns that we allowed developers to implement in a serverless environment. Now, some people think of serverless and they're like, wait a minute, state, aren't they supposed to be stateless? Well, we think that you can actually do stateful as well. And so we started out with orchestrations, so kind of these workflow patterns, and we supported a whole bunch of them, function chaining, fan out, fan in, etc. But there was something that was missing. And we think one of the patterns that a lot of customers wanted to implement in serverless was you could kind of summarize it as like a event aggregation, right? So I've got some sort of function which manages states, and it might be receiving a whole bunch of messages either concurrently from different places, and the orchestration support that we built was just really not well designed to handle that.
Okay.
And so that's when we got in contact with Sebastian and Microsoft Research and said, hey, maybe we think we can maybe model this pattern using something like actors. Let's collaborate, let's talk about it and see how we can do something cool here.
Awesome.
So we just kind of want to add more patterns to Durable Functions to help customers solve their stateful problems. So traditionally, we had kind of 3 different function types. You've got kind of your client function, which is just a stateless function. This is like HTTP trigger, Q trigger, any of those.
These are the traditional functions that we're used to that can basically kick off, I guess, the durable workflows.
That's right. That's exactly right. And then we had kind of this orchestrator function, which this one was definitely a stateful function. Long-running, durable, survives VM crashes, and those sorts of things. And then the orchestrator functions could call activity functions.
Right.
Like in sequence and parallel, you're able to orchestrate these. And so with the new Durable Functions 2.0, we have kind of a new function type that we're introducing, which is the entity function. And this, it's blue. This is another stateful function type that we're introducing. And one of the things that was important to us is we didn't want to just build like some new kind of actor framework. We wanted something that was very much tightly integrated into the Durable Functions family,
Sure.
and not just kind of off by itself.
Right.
So we had a bunch of bindings already for Durable, and so effectively what we did was we said, okay, let's add these entity functions, if you will, and let's add support for like your client functions to be able to invoke these. Let's add support that orchestrators can call these things and get responses back from them. And then the entity functions themselves, they have a bunch of operations that they can perform.
So one of the things that really struck me, and I think this may have been in the documentation, but was the idea that orchestrations as is are sort of implicit state. And so by the pattern that you use for the orchestration, whereas the entity functions or durable entities are explicit state. I'm very tangibly saying, here's a piece of information I want to persist and mutate in a certain way. So.
Yeah. So you can totally do that. And maybe, Sebastian, if you want to talk a little bit about even like the name. So we talk about this as being like the actor pattern,
right?
But we're calling them entities. But maybe, Sebastian, you can share your thoughts.
The name entity is interchangeable to some degree, but I thought it's not bad if you have a name where people don't immediately think they already know what it is. So they can think a bit like, how does this work? And there are some differences here. So at the surface of it, yes, they may look like actor, but perhaps the biggest difference is that you can use them together with the orchestrators. And that's not something you get in an actor framework, the orchestrations.
Right.
And having both of these things together is actually unlocks new possibilities that you don't easily get in a pure actor framework.
Well, I like that you approach the naming that way too, because I think sometimes people get confused when you name a technology after a pattern. And it's like, oh, is this just the pure implementation of the pattern? And so to your point, this is something that interacts with the durable functions as is.
Yeah. So it's this interaction, I think, which will in the end really make it productive. And productivity really is kind of the key word in all of the serverless space. I mean, it's the point where programmers want to be able to write their services very conveniently. And I think that's also something maybe that's a little different here from classical actor frameworks. So all of our communication goes through durable queues. So we are persisting all the messages reliably. And that, in a traditional setting, people would have thought, oh, this is too expensive. We shouldn't, force everything to be so persisted. But when it comes to productivity, that really unlocks something. Like if you don't have to worry about the difference between something being in memory or on disk, if you can just write your application logic, I think that's really what bringing state back into serverless is for us what that means, right? That's the durable part of durable functions.
Well, and the nice thing about it too is you touched on several elements. One is productivity for the developer. And I can focus on my code and my logic without worrying about the underpinnings of how that's scaled out, how that's replicated, how that's duplicated. And that's the other part of serverless is that scale out.
Yes.
And I love that there's a way to deal with state that I do some very atomic operations and say I want to change this or do this.
Right.
And all the distribution and scale out is handled for me. In fact, it can even scale out now on different backends as well. So that's pretty cool.
Yeah, for sure. Why don't we jump into some code?
That sounds good.
And see what this actually looks like. So I'm going to switch over to, let's see, my Visual Studio project that I have here. So when we first kind of announced support for durable entities, the first experience we had was kind of a very much consistent with the Azure Functions programming model. We had just a straight entity function, very much untyped. So if you're familiar with like, more typed actor frameworks, it felt maybe a little foreign to you. If you've done aka, maybe this is kind of familiar. But the basic idea was that, I've got some function, it's got an entity trigger, and it has some context object, which you always get as part of the function. You can fetch the state using a getState method and format it into whatever shape you need it to be. Each operation that you invoke has an operation name, potentially. And depending on what that name is, you can read the input of that operation, modify some state. In the context of an orchestration, you can send that state back to an orchestrator. And then, we have an operation to where you can explicitly save your state.
Okay.
And so this was kind of our first iteration for doing this. Again, very much untyped, but consistent with the existing functions programming model.
Okay.
And again, you can do things like write an HTTP trigger function, and you can send messages to these entities. They have an entity ID, which is basically what is the effectively the function name, and then you get to give it some unique identity. And then you can send messages to it. And you can also do similar things from orchestration. So very similar to kind of the orchestration model that we had, except now instead of writing orchestrator functions, I'm writing an entity function.
Right. Makes sense.
So that works. But you notice the switch statement. Some people got a little bit nervous when they saw the switch statement because they're imagining, well, what happens when I have more than like 2 or 3 cases that I need to handle. So what we did in our more recent release is we created a typed model, which I show here, where basically you model your entity as a class.
Sure.
So in this case, I have a new class. I'm calling it counter. All it does is just store, a value, and you can increment that value. I model the state just as a property, and you can declare kind of exactly how you want to serialize that thing. And then all the operations are just methods. So add method to add some value to your state, reset or get. This is exactly the same code that I had in the other side. But this time it's modeled as a class with methods. And then we have kind of a little boilerplate function that you have to add here. But that's basically it. Kind of a nice, clean model that a lot of .NET developers we think will like.
Yeah, so far I've taken an existing project that was using storage as a backend that was really just to maintain state the same way that you're doing, and the conversion process of adding durable entities in, it just made sense and it just worked. So I was very happy with that.
Oh, good.
Great.
Good. So why don't we fire this up and just kind of show, I want to show a little bit some of these in action. So I'm just going to go ahead and F5 this project. We shipped this sample. If you go check out our GitHub repo, it's there. So I'm just firing up the functions host right now, and looks like that's ready to go. And I'm going to switch over to another command line window that I have. And in my command history here, I've got some commands. So one of the things that's cool about durable entities too is, because we're running in the Azure Functions host, and the Azure Functions host has kind of these built-in HTTP endpoints, we actually made it possible for you to invoke these durable entities directly from HTTP.
Okay.
You don't necessarily have to write a function to go and then send a message to it. You could just send an HTTP request directly.
Nice.
So I thought that might be kind of cool to show off here. So what I'm going to do is I've got this tool that I like. The command line here is just HTTP. The tool it's a Python utility, HTTP-Py, which allows you to send HTTP requests to any endpoint, and it's really good with JSON formatting and stuff like that.
Awesome.
But what I'll do is I'm going to go ahead and try to query some counter entity. Now, we'll call it my counter 3. Now, this entity doesn't exist right now, but we're going to query it anyways just to kind of prove that, okay, this thing doesn't exist. So I do an HTTP get, and I get back 404 not found.
And now, just so I understand for this URL, this is because you declared it as a durable entity, it's automatically created a URL for us to access all those entity operations?
That's right. So the functions host has kind of built-in webhooks. And we were able to register some new ones when you install the durable functions extension.
Okay.
And so under this durable task URL prefix, we have something called entities. And then after that, you can specify what is the type of entity that you want to query or want to invoke. And then, what is the kind of the unique ID of that entity, if you will, or the key, I think is the terminology we tend to use. And so it's just built in, and then you can immediately just start using it.
Okay.
So we queried it. We saw that there was nothing there. So what I'm going to do next is actually try to send a value to it. So with this tool, I can just say I want to send the value 5. Instead of a get, we're going to do a post to my counter 3. And what I expect to get back is an HTTP 202 accepted. So we sent actually, wait, sorry. One thing I forgot is we have to specify what operation we want. So basically, I think at this point we probably created it, but what happens normally is that when you send a message to your entity, if it doesn't exist, we'll create it on the spot.
Right.
Now, because I didn't specify an operation, it probably created it, it saw a message, and it's like, I don't know what to do with this, it just kind of ignored it. But what we allow you to do is specify an operation on the query string here, in this case, add. So if you remember, we have an add method that we defined in our entity class. It takes in some integer amount of data. So in our command line, we're going to send a 5 to this. And that's just going to update this current value state that we have. So let's go back and let's do that. And we should get back another 202 accepted.
Okay.
And so at this point, what we should be able to do is we can go and query this again, and we should be able to see that now we have our state. The entity exists, and we have some state. And so if I wanted to, I could also send, let's send another number. How about we send a 3 this time? And that's going to basically go through the same process. It's going to accept that message, and then when we query it again, we should see that the value is, maybe the timing wasn't
you
quite
did
right.
my counter 2,
Yeah.
I think.
Oh, my goodness. Okay.
Okay.
So now we have a my counter 2, which has some value. Sorry about that. So let's go back to this one and change it to my counter 3. It's all very dynamic here. So we do the add there. And now if I query, let's see, make sure I'm querying the right guy too. So my counter 3, we do HTTP get, and
There
we
you
get a value
go,
back
8.
of 8.
Okay.
Durable entities
You
can add.
Yes, durable entities can add. And so you can imagine that, obviously this is a very trivial example, but in some cases it's still very powerful. Just like actors, we support things like kind of managing concurrency for you. So if I had sent a whole bunch of these commands concurrently, behind the scenes we have a dispatcher which is going to serially execute those so that you don't have to write, locks and things inside of your code to manage that concurrency. So it's super convenient.
So that's another thing we think that is missing currently from stateless functions, is the ability to synchronize things. So if you have a conflict between requests, you need some way of making that happen. We have seen over and over how people struggle with that, like trying to make things exclusive or having singletons or
locks and checking e-tags and all that.
E-tags, exactly. E-tags are complicated.
Right.
It's not
Concurrency is never fun.
No.
And I love this. So this, you just dispatch an operation.
Yeah.
And it's guaranteed that no 2 operations will happen simultaneously on the same entity.
Exactly.
And so then it just flows through and gives me, I love the example, by the way, in the preview docs. They talk about if I have an IoT endpoint and I'm picking up different metrics, I can key off the metric type and aggregate the counters as it's going. And even if I have millions of devices, I don't have to worry about, oh, there might be 10 devices concurrently accessing it. I know those messages will come in order, which is really nice.
Yep.
Yeah, and this also scales up to potentially millions of entities as well. This is the virtual actor pattern that we're following here, and so when these things aren't executing, we're able to safely unload them from memory, and then only when some operation arrives for them, we can load them back up, get their state, do the computation, and then take it back out of memory again, so that which allows you to scale to large numbers of these.
Yeah.
So this is available right now in Durable Functions V2 preview.
Yeah.
Yep.
Is there anything specific on roadmap, any timelines? I know I always put people on the spot when I ask that, but any big things you can share as far as what's going into it before the final release?
So I guess what I can say is that as far as the programming model goes, we feel pretty good with where we're at now. There are a few nice things that we want to do to better integrate it with functions. For example, make it easier to kind of access your bindings from these types, as well as better integrate with dependency injection, which was something added to Azure Functions V2. So we're gonna tie up some of those loose ends, and we're also investing in some alternate backends that you can use to power this. So right now everything's stored in Azure Storage,
right?
Which is great, but Azure Storage has certain kind of scalability and throughput limitations, and so we think people that really want to do some very serious workloads, like serious IoT type workloads or gaming or whatever, might want something that's a little bit more performant. And so that's an area where Sebastian and I are working together.
I think long term, this is actually part of the story. Is just like we saw with garbage collection. When it first came out, people said, this is too expensive, I don't want to use it. But now everybody uses it, and you're ready to pay that cost because it makes it so much easier.
Right.
So I think with stateful serverless, we have a similar story. Initially, it will look like it's too expensive. But in the long term, you just see what it buys you, and as we make those implementations better and better, the cost is actually becomes very acceptable. It's not really
which is one of the appeals of the serverless architecture, is that low cost scale and the fact that I mean, that's what I love about durable tasks in general, the durable functions, is being able to take something that is long running on the calendar, but compute time is actually really short, but you're just asynchronously waiting for all these things, so it works out really well that way.
Yeah, it's actually a good mix for that,
Awesome. Did you have any more code or anything else you wanted to highlight?
I think that's probably good for now. We have more samples in our GitHub repo, so if you're interested in seeing kind of more end-to-end type samples, a little more complicated than just this counter, Sebastian put together a few of them there, kind of under samples. Actually, at the time of right now, you have to switch over to our V2 branch.
Okay.
That's one thing to be aware of. It's not in our master branch. We have a branch called V2. You can find some really cool samples using durable entities.
All right. Well, I will check those out. And just to make it easier on you, we put together an easy link so that you can get started right away. You can read about the preview. You can link in to the various features. You're going to go to aka.ms/durablev2. That's all one word, no spaces, durable V2. That'll take you right to the documentation. Thank you both for coming out and sharing this. I'm super excited about what's coming out.
We are too. Thanks for having us.
All right, appreciate you.
Thanks.